Yeah. So everyone else, did you get the same answer as siapa ni? Yap Yap
Yes, Doctor.
Okay, get the same.
Dapat sama.
Dapat sama Sekejap sebab saya pun baru calculate tadi. Sekejap. Let me check. Ada tak orang yang guna cara lain? Anyone did using the Lee Kessler? Ada tak? Semua pakai second varial Sorry? Yang pakai table kat belakang tu Lee Kessler. Ada tak orang yang buat pakai Lee Kessler? Yeah, but it's very close kan? Sekejap. Okay. Betul. Macam saya explain hari tu, for the Lee Kessler, dia apply untuk, it can be applied to all range of pressure. Tapi for the second varial, fix the correlation for the second varial, it applies for low pressure. Dan advantage of using the second varial is the calculation is much simpler. Kan tadi macam you nampak dekat sini, you just need to determine B0, B1 and it's a function of TR kan. So the calculation is much simpler. So kalau pressure dia rendah, kita memang selalunya akan terus guna second varial. Okay, sebab calculation dia lebih simple, tak perlu buat interpolation. But of course you can use Lee Kessler jugalah and you will get a similar answer. Okay. Cumanya, sekejap ya. It's just that for your calculation here tadi, mana B1 tadi you dapat, kenapa I dapat negatif 0.0775? Everyone else, did you get same as Yap 0.0475 ataupun dapat negatif 0.0775? Ke saya yang salah kira ni?
Total, I get the positive number.
Positive number.
Wait, let me check. It may be. Did I?
Total same with Yap.
Same.
Yeah.
Lain pun sama
Got same with Yap.
Saya yang salah kira ke? Sekejap
Confused.
To the power 4.2.
So maybe it's either maybe it's either your TR. Your TR is same with mine.
Yes, same.
If same, then maybe two possibility. Maybe doctor press your calculator wrong, or maybe there is some sign doctor put is wrong. Maybe.
Let me check. Dekat nota tu salah. Actually it's supposed to be 0.0139. Tak pula, sebab saya tak bawa 0.139. Sorry. It's Oh, okay. It's supposed to be 0.0139. Saya check balik. Sekejap.
Yeah, doctor. 0.139, right? In the book, textbook, page 102.
Oh, okay. Saya tersilap tengok lah ni. Okay. So that should be the answer lah. Yeah, it's 0.139. Okay, so this one is correct. Okay, alright. So in case ada tak sesiapa yang guna Lee Kessler? Can you show me your answer? How the answer for Z0, Z1, and then what did you get for Z? Ada tak yang buat pakai Lee Kessler? Because I did using Lee Kessler also just to show you, yeah. And mana jawapan saya? Oh, sini. Mana saya nak tulis?
So basically, if using Lee Kessler, just you need to interpolate with the table behind, right? Using the Z.
Yes.
Okay.
You just need to use the appendix E. Okay, maybe I will just write somewhere here.
Okay.
Let me share my screen. Okay, so as I mentioned just now, normally we will go for the second virial as our first choice lah when the pressure is low. But if you use the Lee Kessler, of course you will also get you will still get the answer juga lah. Mana saya nak tulis? Okay, here. So if you use the Lee Kessler here, in this case, your okay, so you need to get the TR and PR lah. Okay, so you have your TR and PR, and then you need to find the range of that TR and PR. Macam mana nak tulis yang senang? So, I think I better use the PowerPoint. It's easier maybe. Let me stop sharing. Okay. Okay, so your TR is 1.162 and then PR is 0.0595. Okay, so you can round this up to 0.06 lah. Okay, so you refer to the table and then you find the range of TR and PR. So PR dia dekat sini. So your PR is in between 0.05 and 0.1. Okay. And then your TR is in between 1.15 to 1.20. Okay. So you need to find the, okay, this is for Z, not lah. So you tulislah dekat sini apa value dia. 9891. And then here is 0.9780. Okay, and then 0.9904. And here is 0.9808. Okay, so you kena buat interpolation. So in this case dia jadi 2 kali interpolation lah because sekali untuk PR ataupun TR, you buat TR dulu, PR dulu, it doesn't matter lah. So you have to do twice, yeah. Okay, so in this case, after calculation, I get the Z naught. Mana saya punya Z naught? Okay, yeah. So I get the Z naught after interpolation equals 0.9873. Okay, so you check your answer here, it must be somewhere in between lah, dia antara yang ini, dua ni, and also it has to be somewhere in between. Okay, dia tak boleh melebihi. Let's say if you get your upper limit is 0.9904 and your lower limit should be 0.9780. So if you get outside this limit, then you know that your answer is wrong. Okay, so you repeat the same thing with Z1, Z1. Okay, again you have to find the range PR and TR. This is 0.05, this is 0.10, and here is 1.15, and this is 1.2. So you take the reading for Z1. Okay, so in this case, I get Z1 as 0.0016. Okay, so Z equals Z0 plus omega Z1. So dapat 0.9874. So your B is ZRP over P. So dapatlah 89.54. Okay. So nampak tak dia, you dapat jawapan sama kan tadi? Yap, you dapat Z 0.9874, betul tak?
Kejap. Around.
Yang you calculate tadi. Sama kan?
Around, yeah. Close.
So yeah, so you can see that at the lower pressure, the answer given by the second virial and the leak acid will be almost same. Yeah. Tapi later when we deal with higher pressure, you will see that the difference get larger. That's why at higher pressure you cannot use the second virial. It become less accurate. Okay. So this is if you do the leak acid correlation for the question 1A. Yeah. Okay. Dapat Alright. So
Total, may I ask?
yes.
Total, so for second virial equation is used for the low pressure. So if question like if I don't want to use the compressibility factor also can, right?
Yes.
Like this question. So it depends on me lah. But with second
Yes.
virial will be more fast lah, no need double interpolation.
Yes, correct.
Okay, doctor. Then how about the decimal places? About because my answer a bit different, just a bit only, because I am using a lot of decimal places. So do I need to? Is it no problem, right?
Yeah, no problem. But
Okay, thank you, doctor.
don't use to normally kalau Z tu, because Z is the maximum is 1 kan, so normally we use around 3 lah decimal point for Z. For V tu if the value is large, like few thousands, then even if you don't put any decimal point also it's okay lah, you just round up the round number is okay. Okay, but for Z normally until the third or fourth decimal point. Okay. Alright, so question 1B, siapa nak buat? So the temperature is still the same, but the pressure now has increased to 40 bar. Okay. Anyone nak volunteer buat? Ada tak yang nak buat?
Maybe Doctor, I just show my answer and let them see whether their answer is same or not lah.
Okay, sure.
Wait ah. Okay. Wait ah. Okay. Okay, for the B, I use the third virial equation. I'm not sure okay or not, but this is what I get lah. I also forgot more.
Okay. So can you move
Yeah, you
slide?
need to do the C.
Mm-hmm.
For the third virial. This is the third virial pixel correlation for third virial equation.
Okay, so
Not sure
okay, so,
your answer lah, Doctor. Guys,
okay,
answer
right.
chain.
So in this case, if you use the third virial, you will use the equation for C0 and C1, right? Okay, betul. Okay. Because I solve using the Lee Kessler actually. So I don't have the values for using the third virial, but your answer is actually very close to Lee Kessler lah. Okay, so
Okay.
if you use the Lee Kessler, your Z will be 0. 0.82 0.814. Okay,
A little different.
0.8814 if using Lee Kessler. Okay, and then the V will be, the V will be 555.19. 555. You dapat 560. Yeah, it's close. Actually, kalau the difference normally if the difference is within 2%, then we can accept. Okay, and
2%.
And then of course if we look at your your jalan kerja, your step by step, and then your final answer, it should be within 2% lah. Okay. So in this case, yes, you can use the third virial or the Lee Kessler. Okay. Ada tak yang pakai Lee Kessler? Did you get the same answer as mine? So for the Lee Kessler, it's the same procedure as what I showed you just now. But in this case, the TR is still the same, right? Because same temperature. The pressure now becomes 40 bar. So if you calculate the PR, you will get 0.79 kan? So 0.79, you can just round up to 0.8. Sebab apa? Sebab dalam table tu dia ada value for 0.8 tepat-tepat. So you don't have to do interpolation twice. You just need to do once for TR kan? So that's more convenient lah. Okay, so for the Lee Kessler, if you can round out the value to the value that is available in the table, then you should do that. Yeah, it's much easier for you. Okay? Faham
Yeah, okay,
Okay.
Doktor.
So for the third variable also we can we accept this we can accept this answer. No problem. Okay, ada tak yang buat pakai Lee Kessler? Do you want to show us your answer? Kalau you buat pakai Lee Kessler, you kena dalam jalan kerja tu you kena tunjuk tau you ambil value apa. You tak boleh just, you cannot just put your Z0, Z0, Z1, just write down your final value for the Z0 and Z1. You have to show us what is the value that you take from the table, yeah, so that we know the process of calculation. Okay, kena tunjuklah jalan kerja.
Okay, Doktor.
Okay, alright.
By the way, Doktor,
yeah.
I want to ask if exam we can. Did I ask already? So in exam we can use the book, right? Is open book or closed book?
It's open book.
So all the equation and the table we can use from the book, right?
Yes.
Okay. Thank you, Doktor.
The appendix, we will not supply you with the appendix. You need to bring your own. That's why you need to have your own copy of the textbook lah. Okay. Sebab nanti you akan guna appendix semua kan. We will not provide you the appendix. You have to bring your own. Okay. Next question 2. Question 2 siapa nak buat? Your batch ni saya tak kenal sangat lah because I think kita tak pernah jumpa kan. You all batch yang tak pernah ada kelas fizikal, betul tak?
Ya, Doktor.
So saya pun tak I mean I teach the ITE masa first year, so saya cuma we had online class back then, so I tak berapa cam lah you punya muka. So hopefully after the semester break we can have face to face class, yeah. So that saya boleh kenal lah. Kalau tak memang saya saya tak cam nanti muka you all. Okay, ada tak yang nak buat soalan kedua? Any volunteer for question 2? Sekejap, saya tengok nama. Chiu Chia Hui, ada tak? Chiu, is Chiu here?
Tak boleh dengar.
Tak boleh dengar? Tak boleh dengar. Yes, we cannot hear you, Chiu. Ada problem dengan you punya mic? Siapa lagi yang ada? Chiu, you tak boleh Okay, kalau tak boleh kita bagi dekat Chuan Shin.
Doctor, I'm not sure how to do.
Not sure.
Yeah.
No. But have you done the question or not? Dah buat tak?
Okay, I done question 1 only.
Okay, tak siap lagi Okay.
Sorry, Doctor.
Siapa yang dah siap? Who can how? Who can how? Dah siap tak? Yup, I know lah you dah siap bagi orang lain pula.
Hai Doktor, saya belum buat.
Belum buat juga. Eng Wei Feng, you dah siap tak?
Doktor, saya pun belum buat. Saya roommate Phuket lah. Kami dah bincang, tak tahu. I mean, saya tak berapa faham lah my problem, Doktor. But question 1 I did both lah, compressibility and also viral.
Okay. Okay lah, so kita bagi Yap lah. Yap saja kan yang dah buat.
No lah, because luckily today I do revision on Thermo, so I quickly do.
Okay, so please explain question 2.
Okay. So for question 2, is generally the equation. I don't have the question, but I think it's if you have the question now, you know. Sorry. So this is my solving way. You need to write as equation first. So I remember is in the question it says it's equimolar. So I don't know. So I put XX first because they are both equimolar. Then you will need to write a balance equation. And then these two, I'm not sure total if I can do this in the exam lah. But because it says the composition of HCl is not very complete. It's 75%. So there will be some of them leave out. So I'm not sure I can do it like this in the exam, Doctor. Can I?
Actually, you cannot put it like on the same equation because for the apa equation tu you kena buat stoichiometric balance kan. What is this symbol? It's not exactly plus kan. What did you write there? I cannot read.
This one is like I just like dotted line, so it's not supposed to be in here. So but I just like note down there is something
okay.
else here. So
Yeah.
maybe in the exam I need to draw something like that lah. And then I put there. Okay lah.
Okay. Yeah.
Okay, so this is so need to note that there is 25% of the HCl is outside and also excess oxygen. So the question is asking for how high the temperature can reach. So we assume 10 more of it. Anything you will do, but I will assume 10 more for here. So since it's equimolar for HCl in and O2 in, there will be 5 more for each. And then 75% for the composition of HCl, so 3.75 more of HCl will be reacted and 1.25 will go up from the reactor. And then this one is the stoichiometry ratio. So 4 more of HCl to 1 more of O2 here. So this is the reacted HCl, so meaning that 0.9375 of O2 will be respectively reacted. So as you can see here, and then also if that's the case, meaning that from this 5 more, the 5 more of the O2 in, only 0.9375 more of them will be react. So this is the rest of the O2 that will go up. Okay, so from the stoichiometry, we can also get these two, 1.875. Just from the stoichiometry.
Okay, yeah. You are missing one thing here. Okay. Because the feed kan, dia bukan oxygen sahaja. It has to be air, right? So you will have oxygen and nitrogen.
Yeah. That's the problem I found just now. Okay.
Okay, sekejap saya.
for doing your own work, no? Not paying attention, no? Everyone not do lah. Didn't do. Strange lah, whole class no do. Never mind lah. Oh, forgot N2 here, Jesus.
Okay, sorry. Yeah. So it's supposed to be air kan? So you have to have, sepatutnya ada nitrogen lah dalam tu. And then because the composition of air we assume as 21% oxygen and 79% nitrogen. So you punya mole of oxygen pun salah lah, because you know
Yeah.
the equimolar is between HCl and air. Yeah. Okay.
Wait, doctor. Equimolar of O2 of air.
So where is the question again? Let me check. Yeah. So the question kan, the feed stream to the reactor consists of HCl and air in an equimolar mixture. Okay.
Oh, okay. Then my wrong lah. So the air will be equimolar with the HCl, not the oxygen only.
Yes, the
Wrong
air.
lah. But the idea is here lah. The idea is here.
Yes. I think your step is correct. Can you just show?
Yeah, basically just need to draw this one and then go down. You need to find this one is MDCPH, not MCPH. I forgot the D here. Basically you need to find the formation of 298 for this one. And then later you need to find the del H1 and del H2 because there is a temperature change from the feed to the calculation you do here. And then you need to do the 298 and then go to this T2 here to find a temperature. So basically you need to find all these three things. So this one, and also this one. So doctor, actually I have a question for this part lah, the finding temperature, because in the textbook is using a try and error method. And before in the slide when doctor is discussing, I actually use this method. It's like cubic equation.
Oh, okay. So you just expand and then you start using calculator. Yang ni macam mana you dapat T tu?
Basically just use the calculator to solve. This
Okay.
Continue here. This one is the integration, right? And then I just do the integration and then substitute inside the number and then find the temperature using the calculator T2 lah. So before this, I use this equation also inside the slide example. I get the answer lah, but there will be two temperature here only.
Yes. Okay. If you can use your calculator, kalau you punya calculator boleh solve cubic equation, then yeah, it's fine. Macam saya old fashion sikit lah. My calculator tak boleh buat cubic equation, so I have to do the iteration lah.
So meaning this method is also acceptable lah.
Yes, acceptable.
Okay. Okay.
Okay, cuma okay, you have to be careful lah. You punya heat of reaction. Mana tadi? Ini 114408 kan?
1140. You mean this one?
This value, it has to be based on the actual punya reaction tau, based on the actual mole that react. Okay, so kalau tadi you letak you punya basis ialah 10 mole berapa you punya basis?
My basis 10 mole of it.
10 mole kan? So in that case 10 mole of it, so that means berapa you punya actual yang Yang ini 3.75
So total it didn't depend on this 75% conversion meaning lah. So is the whole, or what do you mean?
It has to, like I said, dia bergantung kepada actual reaction yang berlaku. So in this case, you have to take into account the 75%. Tadi yang you kira tadi mana? Berapa tadi?
114 here.
This is the, kalau you ikut the stoichiometric balance kan? The original equation, betul tak? For HCl, this is based on this one, right? But you have to consider the actual reaction that happened. So in this case, berapa
Oh, so
banyak
the mole here should be multiplied with the mole here, right?
Yes.
Okay. Understand already.
Okay. So you have to be careful, yeah. The heat of reaction must be based on the actual reaction that happened. Okay. So it depends on you ambil basis berapa. Kalau you punya base tadi berapa mole, 3.7 something, then you have to times that, ataupun you kena kira balik lah, ikut follow the same ratio. Macam macam saya buat basis saya 4 mole of HCl. So in that case saya just I just times 75% lah, because I assume 4 mole, so it follows the original stoichiometric punya equation, and then because it's 75% efficiency, then I just times 75%. Okay. So you have to consider itulah. So it's a bit tricky there, Okay, so basically the step is correct. It's just that you have to calculate again the number of mole, actual mole number in the inlet, and then how many reacted, and then also the outlet. Okay. Ada tak yang dah siap soalan ni? All of you memang tak siap lagi Or maybe I can give you around 15 minutes, boleh tak you try by yourself, okay? Sebab I think it's important for you to try by yourself, ya. Kalau saya bagi saja jawapan, nanti you tak buat, you tak boleh experience tau, you tak rasa macam mana, the step by step calculation. Nanti bila test you tak boleh buat. Okay, so you have to try by yourself first, tengok dapat tak jawapan. Okay, boleh tak kita I give you 15 minutes. Sekarang is 2:46, so at 3 PM saya akan appoint someone else untuk to check the answer again. Boleh tak untuk question 2? Okay, you pun recalculate You check balik you punya mole number, and then you recalculate the value. Boleh? Okay? So kita break sekejap at 3 PM, we will start again.